this size and nobody could hear us in the back row, but with a tile floor, I think.
Yeah.
Hey,
Apparently
you got the message.
uniform.
That's
Yeah.
right. That's right. All right, Bob. Thanks.
Thanks for coming. Hey, thanks for having me. I was supposed to be in Singapore this week and last week, but it turns out obviously I'm not there. But I said, what was the next closest weather that I could get to Singapore? And I said, well, Florida. You know, it's hot, humid, surrounded by water all the time. So here I am. Glad to be here. Are we good? There we go. I did notice the little handout that says starter cities. Well, you got to start someplace, right? So we're going to start and become smarter. And when I talk about city, and I say this, and I spend a lot of time outside the country, mostly because my wife keeps me out. She's in the other room, so maybe I can't use her as examples today. But cities can be anything from what you think of as urban centers, right? They can be small. They can be Air Force bases, they can be military installations anywhere, they can be big universities. We're working with university because on any given day, a university could have 30,000 to 40,000 people show up. That's a city within itself. So when we talk about smarter cities, just because we call it city, don't necessarily think of city. But the important part is, when we do talk about smarter cities, do you know that there's 180,000 people a day moving into urban environments around the world? 180,000. And we're not generally creating new cities. Some areas of the world, you know, Doha, Qatar, is a growing city and building out with a lot of new infrastructure and things. But in general, our cities, especially in the U.S. and old Europe, are not ready for this. I remember I was doing a presentation in Manhattan. It was probably 7 or 8 years ago now. And I walked out the side of the building I was presenting in, and they had the street all torn up, of course. I looked down in the hole. You know what they were doing? They were replacing the wooden water pipes running through the city. This is in Manhattan. So, you know, you think of New York City as being, you know, ready for everything they can do. They tell us, right? They can do anything for anything, anytime. That's an example of every city in the world, just from the water side of it. Not to mention the whole, you know, street and traffic, and we'll be talking about these different areas. The other part is, our cities do generate 80% of our global GDP. So we as a country, we as a human race have to figure out how to make these cities smarter because they're typically landlocked in some way. And we got to help them get smarter about how they do their business. So let's start out with a little YouTube video.
Cities haven't changed much in a very long time. 3000 BC, we can imagine a city in the Middle East with walls, where people were sleeping in some houses, others were teaching children in schools, people were sick were gathered in another building, and those that needed to be watched were in a jail. That hasn't changed very much until the last 20 years, when electronic infrastructure has dramatically changed cities and transformed them for the first time in 5,000 years. With these wonderful benefits and the great improvements in standard of living come some serious problems, and the cost of city problems and challenges has a significant impact on the GDP in most cities each and every year. By 2025, half of the developing countries' populations will be vulnerable to floods and storms. And cities are now very focused on ensuring that schools and technical and further education institutions are providing the education necessary for their young people to exploit local job opportunities. Of course, technology can have a profound effect on cities, and cities are moving to a buy, not build model to apply technology rather than be concerned about the supply of it. As they do so, they're collaborating in ways that were previously unable to be considered. Innovation abounds around the world, not just in the Western world. Integration is a constant theme. People are realising that these old structures that resulted in everybody developing separate and independent capabilities is giving way to leveraging each other and really getting much better value from money from the resources that citizens spend to provide these services. But one of the underlying factors here is the impact of data. Harvard is talking about the rise of fact-based management. We have made careers using experience and judgment and doing our best based on what we think is right. That's fast giving away to empirical data driving decisions that really make a difference. It's not just analysing what happened or understanding what's commonly happening now, it's modelling what's really happening in a much broader scale, and of course, the Holy Grail, predicting the future. In China, there's been a very strong focus on traffic management and changing the way in which congestion is having such a negative impact on the economy. Netherlands, a city that's wrestled with the sea for centuries, has implemented a leading-edge digital Delta program for the management of water. Miami-Dade County, one of the biggest cities in the US, is pulling together a fabric of management around their city based on electronic capabilities. Eindhoven is one of many cities now building a traffic management understanding, which leads to better policy and ultimately the use of road user charging to improve the way in which cities manage their transport assets. We're hearing more about cities with vitality. You can feel it. You go into some of these cities and you feel like the city is up and really focusing on these issues and integrating smarter systems, smarter services and delivery to really help individuals and the society reach a full economic, social and health potential. It's all about leadership, and I encourage you to think about the kinds of things that might apply in your city and the ways in which IBM can help. Thank you.
So as Michael said, cities, or however you might define a city-type situation, is really lacking visibility. If you look at understanding how the different parts work together, we have, let's start down here, situational awareness, understanding what's going on at any given time from either your citizens or other people affected by your city, understanding what's going on, and the question is, are you reacting to a situation, or are you going into a situation because you already understand that it's gonna happen, right? And we have very much limited intelligent response because we're so disconnected either by our departments, either transportation, water, city administration, the permitting process, the budget. They don't talk to each other. I don't care what type of, it starts at IBM, the cities, the US military, to UK, MOD, go around the world. I don't care. I talk to a lot of both private and city people. We all have that. I think it's a human nature problem. We just don't tend to talk to each other when we get outside of our silos. Certainly the incident management. I'll talk more about this later, but the number one thing that came out of the Senate hearings following the 2013 Boston Marathon bombings was they were ready for that incident. They were ready for that incident. They didn't want it to happen, but they were ready for it. And the number of lives that were lost because they were ready for it was untold. They had the hospitals ready. They had the emergency management ready. They took care of it. Like I said, I'll talk more about that later. Cross-department collaboration. If anything from permitting process. If developers think they can get through the permitting process with your city or your organization, they're going to come to your city and develop new stuff and create a bigger tax base and bring more people to your city. If they think the process is arduous, they're going to go someplace else and do it. I've talked to a number of cities in the U.S. where I talk to the developers and they say, I can't get through the permitting process, so I'm just going to go build someplace else. And it's a huge problem. And then finally, Big data, and that was actually what I was going to talk about in Singapore this week, was a big data example. So I brought it with me so I can talk about it here later. But the problem is, I've never walked into a room where somebody says, man, I wish I had more information. I think it's almost always the opposite. I have so much information, what do I do with it? How do I synthesize it? How do I make sense of it? How does it work for me instead of trying to wrestle through it? And I can show you a couple of examples that if you're not, well, I guess it's my job to convince you that it's good stuff. So that's what I'll do. So within IBM, when we look at a city, it's more than just infrastructure, it's pieces. You know, it's everything from education, as we're talking about here today, and in many instances, education starts with the children, right? That they're going to become our future citizens that are going to be taxpayers. They're going to grow in and become our leaders. But you have everything from healthcare and social programs. How does that fit in to the city? Clearly, those are huge issues in today's society, and how they're going to be resolved and make a big difference on how we get smarter. Public safety, policing, understanding where the bad spots are, and I'll show you later again where I'll give you a web page where you can actually go out and use our IOC product and play around with crime statistics for whatever city you live in. And it's something that we're offering now that you can get your hands on and start using it. City planning and operations. This says infrastructure. How do you plan for the infrastructure? How does your city say, hey, I'm getting ready to repave this street, and I repave the street, and then 3 weeks later somebody comes and digs up the street to get to the water pipes or the telecommunications, right? How do you prevent that? That's obviously a waste of money and time, and so how do you schedule and prevent that? And like I said before, how do you set up the event permitting process of encourage people to have a good permitting process where people say, I want to come to this city and help build out the infrastructure and make this city smarter. Buildings, energy, water, and we'll talk more about primarily on this side in a little bit. So, as I've said, cities having them effectively managed, just like any organization, private or public, effective managed city is important. And it's not reacting to things, it's being proactive with things. And as Michael talked about in the video, prediction is the golden nugget here, right? Everybody can react to something that's happened, but being prepared, or in cases of water, transportation, emergency management, a lot of other places, we're developing to the point where you need a prediction. So we can tell you what the traffic is going to be like in 15-minute increments for the next hour, right? And with accuracy. We can tell you, and everybody says, well, I can do this on my local weather channel, but we can do microclimate analysis down to a 200 by 200 meter section, and we're using it today in Brazil, right? So it's information. Data. We all, like I said before, we have the data. How are you using it? How do you move in it to work for you? And finally, the biggest piece of, I think, what's been lost is people tend to forget whether you're talking about citizens or the people that are working for you. And we're working with a private corporation in the Houston area that I won't name, but they're actually coming up with a program where they're going to engage their employees on green initiatives through the city. And the city and this corporation are going to work together. And it's a collaboration around some green initiatives. But we'll talk more about this, but there's ways to engage the citizens. There's ways to engage the employees to work for you through social collaboration. So as I talked about, the key part of it is data, right? We're IBM, what else are we going to say? Right? We've built these products. There's a lot of point solutions out there, and that's kind of what we talk about is there's a lot of point solutions for everything I'm talking about here, but the key is, do they work together? Do they bring the data together? Do they analyze it at a level such that it makes sense? So if you're bringing in structured data and unstructured data and other data and bringing it all together, who's going to synthesize it at the top level and make sense of it? Situational awareness, understanding, like I said before, something happens, understanding what's going to happen, and then finally the stakeholder collaboration of getting the citizens involved. That's going to be key. So we're going to move right through here. So what we talked about and what Chris talked about is, and Bert is going to show over here this afternoon in more detail, we have something called the Intelligent Operations Center. And this can be used in public or private enterprise. It's a event-based system, and we're IBM. We've been around for 103 years. We're good at taking data. We've developed a lot of products that are now out in the marketplace around databases, application servers for the whole internet phase. But so everything is built here, not surprisingly, on IBM underlying software technology, and that's kind of key. Is we control how your experience is because we understand the products that make it up. And then more importantly, and I'll talk about later on, when we start getting to big data, we also have a pretty good history of hardware. And so making the hardware talk uniquely to the middleware, which runs all the top layer pieces, is a unique proposition in the marketplace. But what we do is we have key performance indicators that say you define them by user. And like I said, Bert will show more of this, but if you have a city manager, he or she has their own space, and they say, this is what's important to me. I want to know if something turns red, in my jurisdiction. I want to know it. You can have one for the police department, the fire department,
A squadron,
a squadron. Thank you.
right? A wing.
Right. So it's all individually defined, and you define it how you want it to look. And like I said, we don't care. You can push as much data, any kind of data you want into it, we'll handle it. Intelligent response, you can have it web-based, mobile-based. We run IOC on a mobile device. I have a client out in Australia, Australian Defence Forces, that are doing it, that are running from a top-level command center down to a mobile device out for the guys in the field. So it's very extensible. Situational awareness we've talked about before, we'll talk more about. The alert management. So, and the enhanced user interface. This is actually, if you look at it, it looks like a stadium, doesn't it? Well, it's because it is a stadium. It's a Miami Dolphins stadium. We use IOC to. They missed this much, do I have to repeat it?
No, you don't. Let's start.
Test.
Test.
Yeah, there you go.
Great.
People couldn't hear on the WebEx, they were connected up.
I have to use my radio voice.
You use a radio voice.
It's not going to last long. So, like I said, we are using at Miami Dolphins Stadium during events and have been for a couple of years down there. Dan Moreno is one of our staunchest allies, and he'll come out and talk about this to anybody that wants to hear about it. So if you want a name, we can line them up. It's like I said, a stadium, a base, university. They're all small cities on any given day, and they have all the same situation. I did talk about mobile operations, and we give you a way to filter the data that you want to see. So how are we moving? Like I've talked about a couple times here. In cities, our information is in silos. What we want to do is move it toward a citywide view. I don't care who you are in the city. You may have an area of responsibility, but at some point your job is going to affect somebody else's. So you need to have that ability to do that. Today, the situational awareness isn't there. We're going to give you the view of a operational level. How does this work from a operational level? Incident and management, like I said, Boston is a good example of this, and they looked at it within city, fire, emergency management, ambulance, hospitals. We're talking to each other, right? Human processing, how to use analytics. So we've developed, and as we get into the specific areas here, we've developed algorithms built on models that will do prediction, like we'll be able to tell you when a pipe is going to fail. Instead of waiting for it to fail, it's a lot more expensive when a water pipe fails and it floods the neighborhood than to go in and say, hey, this thing's going to fail, let's schedule it for maintenance and replace this part of the pipe, right? And then finally, a bunch of custom solutions. They're hard to scale. So our experience is we certainly work with a lot of partners and vendors that have more experience in this space. But I can tell you, people are surprised. I remember I was at a event last year in Australia at a water event. And we had a big IBM booth and we're all standing there. Number one question was, what in the world is IBM doing here? You're at a water conference. You're IBM. How does that make any sense? So then I turned, I introduced him to a guy on my team that's a water engineer, right? I have a transportation engineer. I have former cops, Army, Navy, UK MOD, Australian defense guys working on our team. See, we've decided and understood that if you're going to talk to people, you need to talk to where they are. So we're going out and hiring those people and bringing them in and helping them understand the value on top of our technology. So here's our little portfolio. The city plan and operations, we'll talk about a little here first. So like I said, as you look at the infrastructure of the city, they're getting older, they're going to fail. And the key is how do you plan for it? I'm working with who knows where Cusco is?
South America, right?
Peru.
Okay.
Yeah. It's actually at 3,300 meters, 10,890 feet. So you get off the plane and you take a deep breath and they give you a little coca tea and you're okay. So we're working with them. And you say, wait a minute, this is a small city in the Andes. Why do they need this type of software infrastructure planning? Well, it turns out that that's the place you land on your way to Machu Picchu, right? One of the new 7 wonders of the world, right? And there's a lot of people coming through there. The other thing is, it's one of the major areas in South America for natural gas. They got a ton of money, and they got a ton of infrastructure issues, and they got a ton of workers come in, and then they have all the tourists from Machu Picchu. So you combine them together, and they say, we got issues. We're thousands of years old down here. Some of our stuff is old, some of our new. How do we plan for it? So they're going to use our stuff. They're going to say, we're working with the state. And they're going to say, we have this much budget. They're just like every place else, right? They have limited budget, they have limited manpower, and they want to know how to organize it. So they're going to use our stuff to do it. They're going to say, we're going to allocate, this much transportation dollars to this part of our state, this much water projects. They're going to build a new international airport. So we're going to help them do it. And they're going to have it based on a asset management system. And they're going to have everything GIS based so they can map out their different projects as they allocate them, and we're going to help them move and move forward.
So one of the interesting things about this, one of the reasons why this is so pertinent for us is we're coming on the 10th year anniversary of our major hurricane Ivan, right? Seems like every 10 years we have a major hurricane that comes in and wipes this place out. So normally what happens here in this area is Highway 98 between Okaloosa Island and Destin gets washed out. We don't have ways of being able to travel that way, right? Santa Rosa County, we have Santa Rosa Island, Navarre Beach area, that gets washed out. So between Navarre Beach and Pensacola Beach, there's no way to be able to travel there. Fort Pickens, that road gets washed out. Not to mention the flooding. Now, we had a great introduction to what we're still experiencing 10 years after the fact in Gulf Breeze, right? We had that flooding of, quote, biblical proportion, where things were underwater, and it was just rain. That's all we had to deal with, right? After the hurricane, after we dealt with Ivan, huge amounts of planning took place. All of a sudden, you're starting to see evacuation routes, better evacuation routes, wider highways going north-south, because as everyone knows who lives here, the one major highway that we have to deal with is Highway 98, right? So this type of software, these type of smart and meaningful discussions that take place need to be taking place prior to the disaster happening, right? With systems like this in place, after or while that disaster is happening, better decisions can be made, actionable items can be made. You know, we had 2 fire trucks in Gulf Breeze swamp themselves. I don't know if you've ever priced out a fire truck, but they started about $500,000 and then they worked their way up, right? All their electronics normally are on the lower level of the truck, right? They thought they could make it through the water. They had to get to a certain place. People were swimming through their windows in order to get rescued, okay? So they didn't have the data that they needed for, you know, the intelligence that they needed prior to going into these areas. Systems like these, mobile platforms, the actionable items that are created from an IOC, this is what this type of systems are about. Now take that from just a city point of view and put that into a campus point of view. What happens if there's a major disaster taking place and school is in session? How do we, all of a sudden our kids get, you know, we get phone calls from the school, we gotta come pick our kids up. I don't know about you, but anyone who's ever had to pick up their children on a normal day, you know, are sitting waiting in line. Imagine what it's gonna be like during a natural disaster. And then on top of that, having to evacuate. So huge amounts of data coming into the mix. People normally don't know how to react at that point. People calling them with solutions while meanwhile they're in emergency mode. Right? Something like this that's put in place before this is taking place or during exercises help mitigate a lot of that risk.
Thank you. Where do I send a check? So,
It's a concerned citizen, right? It's part of that whole citizen
yeah.
thing. Right?
So you notice I did skip over the water. Certainly water is important. We're not making any more of it, as we've heard, right? It's a limited resource. And the question is, you know, how do we take care of it? And like I said, when I travel around the world, we have issues like in South Africa, right? We call it non-revenue water, which means water's leaking away, someplace they don't know why. The average around the world, the average for non-revenue water is 21%. So 21% of our water, clean water, is leaking away, and our water companies don't know why, right? Or don't know where, more importantly. In developing countries, I was in Durban, South Africa, and in the city of Durban, it's fine. It's about 24% non-revenue water that they were trying to address there. But the problem is, when you get out to the villages where they really need it, and they don't have other water sources, it was between 65 and 70%. Just gone before it gets there. So, you know, the villages that need it didn't have it. Places like Australia, from Perth, there's a reason why in Australia all the cities are on the edge. It's because that's where the water is. There's a mining town 600 kilometers east of Perth. They have no water. They got all the, you know, mining money and everything in the world, no water. They have to ship from Perth 600 kilometers to this town. And it's a huge cost. They lose on every liter they send, they lose money. So they got to get smarter on how they do it, and we're helping them do that. So video analytics, this is a neat area. We're doing some amazing stuff here. We brought a new group into our group this year around video analytics. So it's everything from physical security with a automated response to other areas. It's reducing the human effort, right? We've done tests, and they're well documented of how long it takes. Everybody thinks, wow, cool, you know, I can build a massive room with screens all over the place. It looks really impressive when you show people and they walk in and, you know, this big wall full of screens and different cameras pointing at everything. Usually there's, between 4 and 6 operators sitting at their own machines, not looking at the wall. They're looking at individuals. You usually just use the wall for demonstrations or when you have a centralized event that you want to show everybody in the room. But typically they're looking at between 2 and 3 monitors themselves. And after 16 minutes, they're missing 80% of what's going on in those monitors. 16 minutes, and they're there for 8-hour shifts. So there's an issue. So the key is, how do we make these people more efficient? How do we tell them when something's happening versus them having to recognize something happening, right? And so that's what we do with our video analytics.
How do you get the real-time information? I mean, those cameras out there are usually storage devices. They're not hooked into an infrastructure. Say the bombing in Boston, there were a lot of cameras there.
Right.
But you didn't get that information real time. You got that information days later. You're talking about real time. How do you do that?
In cities, they are real time. London has 70,000 cameras, right? And they're real-time cameras. They're hooked into an information center. If you talk about like convenience store videos, and those did come into play in Boston, right? You're absolutely right. We had to pull them off a tape. But we also use those because we can run them through the system and say, I'm looking for a guy with a ball cap and a blue shirt wearing glasses.
You're saying real-time information was available off those cameras in Boston when they had the bombers blow that stuff up. Is that correct?
That's right, but they weren't using our stuff.
But there was real-time information available.
That's right. Yep, yes, sir.
Do you know if the FAA is using any of these algorithms for air traffic control now?
I wish they were, as much time as I spend in the flights. I don't believe so. I've not heard of that. No, we do a lot of stuff with the U.S. government. I don't believe the FAA is one of them right now. So let's go ahead to the button. So let me show you how we're working this. So what we have is a video management system. So we hook up to a number of them that are generally available out there. Genentech is the biggest one we hook up to. And you have live video. Can you stop it for a second? Thanks. So a lot of people are confused because people watch TV, right? And they watch CSI and other programs like that. Hollywood is not even going to say they're great. But they have a stretch view of reality, and that's their job, right? Our job is to say we're not there yet on most of what you see around video analytics on TV, right? We're getting there. We're surprising a lot of people with what we're being able to do. But the key area, and I'm going to contradict myself in a minute, but the key area is that in most cases, it has to be a still fixed camera. Scanning major areas for data and intelligence is not going to get event-driven response. You can have an operator looking at a scan camera, looking at broad areas, but that's not how it works. So what we do is we take it from the video management system, hook into it, and we use our analytics engine. And if you see, let's go ahead, we look at every object that comes across our screen, and we give a unique identifier. And we put it into our analytics engine, and with the middleware from IBM, drive it and track it down into our metadata engine. So what that means is we're taking the metadata, and that's how we can do the analytics and the prediction off of it, right? And the searches. So we're taking real-time information and saying we want to look for it, and we send it over to our operations center. So you can do forensic searches, and we'll talk more about that in a minute. So what we do is we're scalable. We have the ability to look at different types of information. Here you see traffic crossings, here you see people. A lot of people say, they can do people counting. That's like, intelligent video 101. Like everybody can do people counting or car counting, right? So how do you get beyond that? We actually, as you see, we're catching every object that's coming through and giving it a metadata number. So then you can go in and say, okay, I want to look for a particular person. Let's look for somebody with a blue shirt and see what we get. So we click on a person, we can look, based on different characteristics. Let's do another search. Let's look for a bald person they may or may not have glasses. We don't care about what the color of their shirt is, so let's see what we get. This lady probably doesn't like that result, but other than that, it was pretty accurate, right? And what we do is, as we look at them, we actually weight them and say, this is a good result or not. It went through there really fast, but we do so many different types of analytics, and we give you weighted results. They'll be green, yellow, and blue based on your definition on how accurate they were. So, imagine, to your point before, if we have recorded video, maybe somebody's driving a white Bronco in LA, just as a broad example. They had to sit there and watch the video, right? They didn't have the way to say, scan this video, look for a white Bronco driving on this section of freeway, at this particular time. There was another sad event, took place in Nairobi 2 years ago. Was it 2 years ago? No, it was just over a year ago. A mall had some issues, right? The Kenyan equivalent of their FBI came to the IBM offices because they knew we had this technology, and they said, help us identify these guys. I'm not saying we can do facial recognition to face match exactly. That's coming. I'm working with clients where we're exactly working on that scenario. But police agencies, typically, if these guys are going to be involved in different events, they probably have a picture of these guys on file. We can help go through those files and help identify those people. We are, like I said, we are moving from, somebody walks into a mall and he's a known bad guy. Pretty soon now we're going to be able to say, alert the authorities, this guy's in our mall. Let's at least go talk to him and find out what he's up to, right? Another one, another use case that we can handle with the software was a direct result of the Boston Marathon bombings. And so we can have a discarded package scenario. So somebody's wearing a backpack, for example. He takes off his backpack, sits it down, and walks away for you determine the amount of time, the operator can get an alert and say, go check out that object, right? So we're moving that direction. And I hinted earlier that we're also moving away from absolutely requiring still cameras. I'm working on a project in Australia where, with a water company there that said, down there they use a technology called pipe rover technology. They send pipes or little roving video cameras through their pipes looking for cracks and blockages and other stuff like that. And they said, wouldn't it be cool if I didn't have to have a guy sitting up there like a roto-rooter man, looking at a video image, looking for something. Wouldn't it be cool if I got alerted that there was going to be a crack in the 600-kilometer pipe out to Kalgoorlie in the middle of nowhere? Wouldn't that be cool if I didn't have to have somebody watching the whole 18 hours of video of why this rover is moving? So we're working with them on that technology that says, alert me with a moving camera moving through a pipe when a potential crack is spotted or there's a blockage. Alert the operator. So think of another scenario where it's not water pipes. Maybe it's a human pipe, right? You're sending a camera through your body. You don't have to rely on an operator watching a camera looking for a blockage in an artery. They can be alerted, right? So think well beyond smarter cities. Think of manufacturing. Think of human health and the body type of applications. This stuff is coming, and we're working on it right now. So our key is prevent incidents. Tell the operator before it happens. Understand abandoned objects, like I talked about, suspicious cars. If somebody pulls up, it's not so common in this country, but a lot of other places in the world, as you pull up, to a hotel in a lot of cities, you pull through gates and there's a guard there, scanning your car, looking for objects. And, if a car shows up and parks just outside the hotel and doesn't have good reason for being there, you could alert on that. You could look for suspicious suspects or vehicles or crowd movements. A crowd starts forming for an unknown reason in a unsuspected place. Alert the operator. Something bad could be happening, but it's better to go check on it than wait for something bad to happen and deal with the results. And then finally, operational efficiency. Certainly, we do a lot around traffic cameras and traffic management centers, having the ability to use cameras in those types of situations. Bottom line is where is it? Manual index search versus, you can see the difference. On 30 to 50 times faster based on just 50 cameras, right? And a small city in the US has way more than 50 cameras. 50 cameras takes it from 6-hour window, 3 incidents, down to a very minimal time, reducing it by up to 10 to 30 times. So some pretty amazing stuff. Finally, transportation. This is an area that frustrates every one of us. I was shocked. Do you all ever have any traffic here? Really? Oh, okay. I haven't seen it yet. So, but a lot of areas of the world, Beijing, you can be trapped for 3-4 months, trying to get to work one day.
Right. I worked on 85 this afternoon between 3:30 and 6:30.
Really?
There's only 80,000 cars.
I guess I'm headed to the airport earlier. Okay, thank you for that advice. I'll take that. Thank you, sir. So transportation, it's a huge area, and we do a lot in this area. You heard Michael Dixon earlier in the video talking about certainly traffic management centers, and it's much more than just counting cars. It's taking data. It's understanding, whether what kind of cars, where they are in the traffic patterns. We deal with a company that controls stoplights for cities, and we're working with them now as a partner because we're never going to go into the business of controlling stoplights, but we partner with them to be smart about how traffic patterns go and when you change stoplights, like for emergency vehicles, right? You want to have the ability for emergency vehicles to trip a light, but you don't want to wait until they get to the light. You want them to trip it several car lengths or several lights ahead of time, right? So by the time they get to the light, it's green, because if they get to the light when it's red, and they click a button, that's too late, right? You want them to have a clear pattern for the emergency vehicle. So we're working with a company to allow that to happen. And same type of thing with school buses. So I'm trying to find out, which school buses and which emergency vehicles have these, so I can follow them through all the flights. But another thing is, there's a lot of different ways to keep track of traffic, right? There's cameras, there's things in the road that count cars, that tell how many are coming. But I think probably everybody, and I see a lot of people on right now, everybody has a mobile phone. Not everybody has a smartphone, but a lot of people have smartphones. We can take that data today, and we don't have to know who you are. We don't care who you are. You don't have to get worried that we're going to look at your phone. But we can take that data and track your vehicle, right? And start building traffic patterns based on that, and that's how we can do part of the prediction. We can take that data. We do road user charging. Some areas that's a big deal. Make people pay if they're going to use it during high traffic times down in Miami. That's a key part of it. Traffic optimization is like I said before, doing traffic prediction, telling at 15-minute increments what the traffic is going to be like, and being able to plan your journey based on it, so that you could get a text on your phone that says your planned route, because of today, what's going on, it's going to take you 20 minutes longer. You might want to consider an alternate route, right? That's one option.
Yeah, it's like that 5-minute rule, right? When you leave your house, you have a 5-minute window to kind of make the traffic if you're used to, going to work at a particular time. And if you're outside that window, then you're 20 minutes late. If you leave 1 minute later. It's just, that's the nature of this.
Okay. Can I jump through this part?
Sure.
This is the emergency management part. I think that's what I was supposed to come and talk about, right? So we can talk about more in the IBM room, but smarter emergency. I think everything what I talked about, leads into the emergency management, right? It's traffic. It's policing. It's events, both planned and unplanned. Whether we're talking about parades or congestion, weather, hurricanes, being ready for those is part of the emergency management. I think we talked a lot about that. I'm going to skip over that. And in France, they use a citizen collaboration, we call it. It's basically crowdsourcing to tell us when things are happening. Whether it's a broken street sign, a broken light, a pothole, we use crowdsourcing to tell the government. And there's two-way communication based on those types of apps off the smartphone. The one I really, really wanted to talk about, and we can talk more about it, but this is for a unnamed defense, national defense in a country that I can't tell you who it is, but basically they have the need to do 100 terabytes of information every day on a regular, every day, 100 terabytes coming through to do actionable intelligence based on that amount of information. And our nearest competitor can do 10. And we've just proven within a number of seconds, based on the query, well under 5 seconds, so we can take 100 terabytes of information and do a query and get you actionable intelligence that says, I'm looking for this type of a suspect, meeting this criteria, and I have to find it in a pile of 100 terabytes of information. That is already scalable to 500 terabytes of information, and we know we have to get to a petaflop very quickly, because that government has told us they're going to be to the level where they need, on a daily basis, close to a petaflop of information coming through their system that they have to get actionable intelligence out of. So finally, as you start looking at it, right, big data, it's not just national defense, right? It's cyber crimes. Who here has ever shopped at Target, right? I know I had to change my card because I got a call that said, Mr. Thimsen, are you in Malta right now? You're not? Well, your card is. Your card is being used right now in Malta, so you might want to change it. So.
Yeah, mine was in South Africa.
Right. Well, I was using it there. So, so financial, right? Fraud is a huge issue. Cyber fraud, financial fraud. We're using these systems to drive fraud out of our systems. Right? So I think I'm being kicked out. So finally, the last thing I want to say is, and you'll see this in the handouts, is you can get on and try this stuff. Down here, you can get on and log on to IOC. Everything we do can either be on-premise or cloud-based. This one's obviously cloud-based. You can get in and try it for free for up to 60 days and just play with it. You can use our data, you can use your data, you can see how it works and just play with it. So, all right.
Thank you so much. I know